I believe that the ultimate source of a libertarian free will is the human capacity to imagine virtually anything and then to enact what has been imagined. But how is our awesome engine of novelty and creativity, rooted in spontaneous and unprecedented recombinations of existing representations and operations, realized in the brain? Capacities that set humans apart in kind, not just in degree, from other animals include capacities for art, music, analogical reasoning, abstract thought, the spontaneous generation and use of symbols, and the ability to reason abstractly, as well as the ability to manipulate symbols recursively and syntactically. I believe that all these modes of cognition share a common root cause. My central claim is that neuronal circuits that were functionally distinct and modularly encapsulated in our chimp-like ancestors came to interact through a new type of attentional binding. Cross-modular binding, where operators previously limited to operands within a given module could now operate over the operands of other modules. That is, I think, the root cause of our uniquely human modes of cognition. Although animals can learn arbitrary associations, they do not use symbols as we do. Beyond lacking syntax, they're not typically able to effortlessly assign or reassign an arbitrary meaning to a given symbol once an association has been learned. It's this arbitrary and flexible relationship between a symbol and its referent that is the hallmark of true symbolic thought, setting it apart from mere association. A symbol has various aspects. One is the perceived sign, which can stand for one or more referents. A sign's referent can belong to many different types of mental representations, which themselves need not be signs. If the mental representation is one of an object or of a type of object in the outside world, then the sign symbolizes that thing in the world. When a sign has a referent, for example, a meaning for a particular perceiver, it's a symbol for that perceiver. A symbol is assumed to possess two key defining properties. One, a symbol is a mental representation that can be stored in long-term memory or held in working memory that can stand for one or more arbitrary stored or online representations. Second, a symbol can be flexibly remapped to an existing or new referent without a need for many trials of learning to build up an association. In other words, a symbol is arbitrary. Its meaning is not based on the likelihood or degree of co-occurrence between a sign and its referent. A sign is simply assigned. Only humans, as far as we know, possess the capacity to process symbols in the sense of two, namely flexible one-shot remapping. A mind capable of one, that is, associative learning that something stands for something else, but incapable of two, namely instantaneous and flexible remapping of an arbitrary sign to an arbitrary referent, can learn complex associations between an object or event and some referent, but the association is not truly symbolic. Classical conditioning is an example of an ancient form of associative learning. In contrast, a 3-year-old child can pretend that a block is a truck, and then a moment later pretend that it's a monster. A child, unlike any other animal, can even pretend that its body is or refers to something else, as when a kid says, "I'm an airplane." This capacity to instantly remap the referent of a representation maintained and manipulated in working memory is, I believe, unique to humans and is at the heart of why our cognition is truly symbolic. Symbols and symbolic thought are inherently attentional in nature because they involve the binding of a sign with arbitrary reference, whether temporarily in working memory or more durably in long-term memory. With unintentional repetition or intentional practice, arbitrary representations can become bound together in memory. This is the relatively slow process of associative learning that humans share in common with other animals. With attention, however, arbitrary representations can become bound together in working memory after just one instance. Attentionally bound symbols and referents can be chunked and stored as a unit in long-term memory, recalled as a unit, and later processed without the need for further attention. However, at the stage of encoding, one-shot binding of symbol and referent occurs because symbols and referents are both held in working memory at the same time.